Everyone, thank you for your patience there. My name is Chris Fantine, Chief Technologist for the West Region at Red Hat in North America, and I'm going to talk about DevSecOps and how Kubernetes can enable that. But first off, there's a lot of pressure on businesses to be innovating rapidly, pretty much across every industry, and businesses have to make that transition from being a static and planned operation to one that's dynamic and policy-driven. And certainly automation is a big part of executing on that. And IT must evolve as well, and that's why you're seeing this evolution to microservices, DevOps, cloud, and containers are a big part of enabling IT to support the business. But what about security? It's typically an afterthought, right? As I talk with customers, typically it's just the operations team historically that are concerned about security, and certainly that needs to change as you make this evolution to a new IT. Certainly with microservices, you're seeing importance on the network. And what about security? Service-to-service communication. It can span from one provider to another. Also, DevOps, the expectation is the ability to deliver quickly in a matter of minutes or hours, not weeks or days. And applications are being spread across multiple clouds or hybrid cloud infrastructure. And so what does that mean to the dissolving security perimeter? How do I address that from a security perspective? And what if there's a security breach into a public cloud? That could have a significant impact on financials because now I'm moving to a consumption-based model. Also, there's an expectation that we fully utilize our resources. How do we ensure that there's a safe harbor for applications to sit side by side with another business unit or another customer? And so that's why you're seeing this movement towards DevSecOps, inserting security into DevOps. It's a cultural change, it's a process change through automation and leveraging technology. You see early adopters leveraging more and more open source solutions, and from a process perspective, treating the infrastructure as code. Right? Being able to reproduce and be consistent across any provider. And certainly open source is an example from a cultural perspective on how to make this shift. Open source is all about being collaborative, transparent, and open. And that's what fosters innovation. If you take a look at where is innovation happening in containers, it's happening in open source. And so what does it mean to make this shift to DevSecOps? It means shifting to the left, not just a operations discussion. Right? It's inserting security into the business, into the product management, and driving it through engineering and testing as well as operations. And you do that by secure coding practices, continuous security testing, everything as code, right? That means infrastructure as well as your application, and leveraging more and more automation so that you have this continuous pipeline of moving applications from dev into production, and you have a feedback loop so you can continuously improve where there's gaps in your security policies or practice. And containers are a big part of enabling DevSecOps. As you move to containers, some of the benefits from a security perspective and a DevOps perspective is one is a container image best practice is just to install the bare minimum into that image. And that reduces the attack vector, a surface, and so you can minimize your exposure to any vulnerabilities that are out there. Also, it provides agility. A container image, an instance, is lightweight, so it can quickly scale up and scale out as you need to, and you can move it rapidly from dev, test, into production. Also improves the quality because the image is self-contained. It has everything that it needs. It has the application and the OS dependencies. It's immutable, and it ensures that you have no environmental differences as you move from dev, test, into production. And that's generally a huge cause of issues as you move from your laptop. And you can build that image once and then deploy anywhere, adding flexibility and portability across any provider. And what are some best practices as you build these container images in containers? First off, when it comes to build time, here's some principles you may want to follow. First off, a single concern principle. This aligns with microservices. That container should do one thing well. Also, self-containment principle. Right? The container should have everything that it needs inside that container. And then thirdly, image immutability principle. Right? It should be immutable. It doesn't change. You build it once, remove the configurations, remove the data outside of the container image. And what about runtime? Right? So a container instance should be highly observable, and you do that by having APIs to observe and manage that container. Also, life cycle. It should be able to read and react to any events in the infrastructure and behave accordingly. Also, it should be ephemeral, short-lived, and replaceable. Right? It should be built to that design. And runtime confinement. So the microservice should specify its requirements, and then the container should be able to limit the consumption of resources of that container so it lives as a good neighbor and doesn't have a noisy neighbor effect on the infrastructure. So those are some best practices on build and runtime of your containers. And this is all made possible in terms of the portability because of the Open Container Initiative. Right? The Open Container Initiative provides a standardization on the image format as well as the runtime and the distribution. Think about the JE spec, right? It provides a standardization around your jar file, and the JVM providing portability for Java, but the container provides portability for any language. What about DevSecOps at scale? Right? A container is great on a particular laptop or shared infrastructure, but how do you deploy at scale? How do you manage containers at scale when you move to hundreds or thousands of instances across one or more locations? You have issues around scheduling those resources so you use them efficiently. You have issues around managing your container lifecycle from dev into production and version controlling. Also about discovering new instances and adding them automatically into a load balance service, or monitoring those services and getting feedback. Scaling automatically up and down so you don't get a page at 2 a.m. to add additional capacity. And what about your applications that require persistence? I want to be able to automatically provision and have self-service when it comes to storage. And my application is no longer a single monolithic application, but it may consist of 10 microservices. So how do I logically manage that and make sure it's distributed across my infrastructure in a highly available manner across racks or across availability zones? And of course, security, which we'll talk about more. And so Kubernetes is that platform. It's becoming the standard to provide the resilience, the speed, and the efficiency, but also Kubernetes can be viewed as a standardized security platform that spans across any provider, because Kubernetes can be installed on physical, virtual, private, or public cloud. So think about that. I don't have to use the cloud provider's specific tools or processes when it comes to security, and I can provide the flexibility to my business to move their application anywhere by leveraging Kubernetes, but also leveraging Kubernetes as a security platform. And so Kubernetes enables DevSecOps with automation. How many of you use Kubernetes? Right? So some of the basics with Kubernetes is that you can define your application, such as a 2 web server, single app server application here declaratively. And then Kubernetes will go ahead and orchestrate that out onto your infrastructure across a set of nodes in a cluster. It will front end those pods, which contain one or more containers with a service and load balance the traffic across that. And it can route traffic from the public internet to your web server in this case. It also can monitor the health so that you don't have to monitor it manually or get pages at 2 a.m. It will automatically detect and recover from a failed pod. Also, it detects increased load. If it reaches a certain threshold that you define, it'll go ahead and schedule additional capacity as well and add that into your load balancer. So those are some of the basics around automation. And here's some of the container best practices when it comes to security and you approach your Kubernetes and your container environments. One is to take a approach of layered security, right? No one knob will secure your environment, but it's a combination that will add additional security and protection and reduce that risk. Also, take the approach of least privilege, right? Don't grant root, don't run your containers as root, limit the privileges that your containers have. Also, reduce the attack surface. As I mentioned, install the minimal that's required for your application. Remove what's not necessary. And make sure that your container is immutable, meaning not changing. So let's talk about some best practices for container images. The basic flow as a developer is that I build my container with a build file. I create the container image. I share that image in a registry, public or private, and then I run it across my infrastructure, and it instantiates as a container instance, leveraging a standard runtime across physical, virtual, private, public cloud. And from a developer perspective, I have to make a shift, right? If I'm developing a Java application, I deliver a jar file today, typically to my test environment, and they build it out and then complete their testing. Now, I'm going to be delivering a container image that I build in my CI process, right? What does this mean? This means my application gets built, it gets put into a container image, but it pulls in the dependencies it needs. Those dependencies may be the language runtimes as well as the OS dependencies, right? This allows my application to be self-contained. I have everything I need except the Linux kernel to execute on a host system. This means that I can have multi-tenancy. I can have this multiple versions of the same application sit side by side. I don't have to worry about whether a library is provided by the host system. And does this mean that the developer takes increased responsibility from a security perspective? No, it doesn't have to be that way, because you can separate those responsibilities and have a converged supply chain, right? You can have your admins continue to provide the base OS image, right? And then the app team can layer on top the middleware, and then the developers can layer on their application code. And then each layer can check for security notifications and update their respective layer, and that becomes the combined container image, which gets launched as a container instance in your runtime environment. And then a best practice around treating them immutable with Kubernetes, what do you do with your data? What do you do with your configurations? Seth talked about secrets, but there's also a config map if you don't need to encrypt the data. So maybe it's an IP address or a string that you need to pass along, or a configuration file that you need to pass along to a container instance. And so that can live in the Kubernetes master server within the key value data store called etcd. You save those in your etcd, and then outside the image, that allows your image to be immutable. And then when you launch the instance, it applies those config maps to the instance, either as an environment variable, or it can mount it as a configuration file. So let's go through an example. Let's say I have a JBoss middleware application server. It has an XML configuration file. I would save that in Git, version control it. I would pull it down and define it as a config map in my application in Kubernetes. It would go ahead and define that as a config map, and in this case, I would load it as a configuration file into the instance at runtime. Right? And now I have my configurations for JBoss, and they're defined and version controlled outside of the container image. Right? So some best practices when it comes to your build files. On the left is a nice short and sweet build file, but it uses the proper formatting. And the first thing you'll notice is you want to treat this build file as a blueprint. This is your recipe for building the image, recreating the image. We don't SSH into a container instance, make changes, and then save that to an image and reuse it, because you don't know what changes were made. And also, you want to version control this build file, of course, infrastructure as code, and be explicit with the versions. Don't use latest, because latest today is not latest tomorrow necessarily. And use a fully qualified domain name for your registry. Remember, each run creates a layer. So the more layers you have, the less efficient your performance will be. And containers run as root by default. We do not run as root in production our container instance, right? A very bad practice. And so make sure you're specifying a user in your build file. And make sure you're signing and validating the images. You want to know that they come from a trusted source. And also, Kubernetes can be enabled with an emission control to make sure that the image is signed, and if it's not, to prevent that from running in your infrastructure. Let's talk about continuous builds. So here's the typical flow in a CI/CD pipeline with Kubernetes. Right? You'll notice that there's three namespaces. I have the development, I have UAT, and I have production. Kubernetes implements network namespaces, which allows you to have logically separated environments on the same infrastructure, physical infrastructure, right? Some folks have one single cluster for all three environments, but more commonly, they'll set up a Kubernetes cluster for dev tests and then have a separate cluster for production at a minimum, right? And so the general flow is that you check in your build file and then you have your build phase, but a best practice is to leverage a build image. A build image contains all the components you need to build your application, and then it will produce a target image containing just that built application and the necessary dependencies. This keeps it nice and lightweight and also reduces your security risk. You then build that once, and now I can push it to dev, test, and production as is. So best practice also from a security perspective is to use a reproducible build model. And why do we do that is that security issues aren't about changing source code or attacking a known vulnerability. Right? Sometimes they're attacking the build environment, replacing the compiler, or changing something in that environment that would introduce an issue that would go undetected by doing a source code scan. And so what you want to do is take your source code on the left here, you have it version controlled. I want to build version 3.1, and I've built out a container image that contains my build environment. And I versioned that. So now, in the future, I can go back in time and rebuild version 3.1 with the exact environment that I used the first time. Right? So this makes it reproducible, right? And minimizes your risk of being exposed to an issue that attack the actual build environment. Also, once you have your image out in production, how do you rebuild? Well, what you can do is you can monitor the different layers in the registry and see if they've been updated. Right? If there's an update, you can trigger a rebuild. Right? This enables the developers to focus on their code and the application team to focus on the middleware layer and the operations team to focus on that, but also have a multiplier effect, being able to provide that benefit to everyone who depends on that layer. And what about container registry and scanning your images? If you pull down, which most developers are pulling down from a public repo registry, maybe it's a C, a Java, a Node.js, or a Perl application, they may be pulling down images that have known security vulnerabilities. Take a look at the second column as the Java. It pulled down an image which contains the JRE, bash, and glibc. Well, there's 66 known security notifications for the JRE. Right? So I need to be aware of what am I pulling down in my environment and how secure are there any known vulnerabilities for those images. And what about in the future? Are there additional vulnerabilities that are going to come out that I need to be aware of? And so one of the things that we see most enterprise doing is first they set up a private registry in their environment so they have an audit trail. They know who pushed that content to the registry. They also, in 12 to 18 months' time, have full control over whether those old legacy versions are still available. Think about that. If you're relying on a third-party public registry, who's to say whether that version that you're using today will be available tomorrow? And what about integrating security best practice into your CI/CD pipeline. Here's a Jenkins build pipeline. You can see build 1, 2, and 3. But what we've added is a phase to do a security scan of the image once it's built. So this could do a variety of checks to ensure that I have a secure image that I'm passing on to my production environment. You could also leverage a private registry which has a trigger to do a scan upon push. There are many scanners out there. This is just one called OpenSCAP. That's an upstream open source solution. It really does two things. One is it does a security scan of the image to see if there are any known vulnerabilities. It also works on a VM or a physical server, but also allows you to do a security policy check too. So there's some predefined policies like PCI compliance to help you out with that. And you can select which rules you want to enforce, and then it'll check your image, and if it doesn't pass any of the checks, it'll actually create an Ansible script to remediate that particular issue that you could run against it. So OpenSCAP. What about CI/CD? So as you move to containers, you may used to patch production by logging into your production box. Well, that's a very bad practice, but the reason you probably do that is it takes too long to interact with developers to create the next version and to push the compiled application through dev test and production. Maybe it takes days or weeks. Well, with an automated CI/CD pipeline that's container-based, you can push in a matter of minutes or hours. And so a good rule is to always go back to development anytime you need to address a security issue and push that through the entire CI/CD pipeline. Build once and deploy anywhere. Right? And there's a variety of deployment strategies to deploy at scale that you can leverage Kubernetes to do, whether it's a recreate, so you have an existing version, you rip it down and replace it, there's downtime. Or you could leverage a rolling update, which has zero downtime, but you need to work with your application developers to make sure that the APIs and the database are backward compatible in the schema. And then also you could leverage a blue-green, which reduces the risk a little bit because I don't touch the existing environment. I just set up a new logical environment and I can always roll back, also zero downtime. And as a developer, I'll typically be doing a canary deployment, right, and testing out that new version at a small scale and getting some feedback. So let's take a look at that. A/B testing with canaries. Only a third of the ideas improve the metrics they were designed to. So it's a very important to enable DevSecOps is the ability to experiment and try things out, to get feedback quickly. And so I'm going to run through an example. Here on the left, I have a mobile app with a recommendation engine, and then version B modifies that recommendation engine. And I want to see what the business impact is. So in Kubernetes, I could do a canary deployment. I could set up a service, and I can use the labels and selectors to route the traffic accordingly. So now I've set it up to route all traffic to version A. I currently get a 25% click-through rate with that recommendation engine. And I went ahead and created version B. I deployed that. There's a health check in Kubernetes, so you can run like a TCP, HTTP, or some sort of script. And once it passes, then it would add it into the rotation. And so here, I updated the selector by removing the version specific. And now it's the route across all the pods. And you see the traffic is 7525, and that's based on the number of pods for each version. Right? So I have one version B, and I have 3 that are version A. And I noticed that there's a 30% conversion rate, so I want to go all in on that new version. And so I could just update the selector and move all the traffic over. Right? If there was an issue or degradation, I could revert back. But what about external services? Typically, I put my application on Kubernetes. I have data that lives outside of the cluster. How do I quickly move and use that external service? So maybe I have a Mongo database in development, production, and I want to be able to switch between the two without having zero downtime. And so what I can do is I can deploy my web app into Kubernetes, and I can set up a service called a cluster IP which is associated with the Mongo. And then within my application, I'll just use the connection string that's static, MongoDB / Mongo, right? And for the service, I associate that with the IP address of the external service. Right? And now it establishes the connection. I didn't have to configure or define that IP address in my application, in the pod. And I don't have to restart it if I want to switch. Because what I can do is I can just update the endpoint. Right? So this provides nice availability and an easy way to quickly move from one version to another or from dev to production. Also, if I have a URI, I could leverage that as well. What about database migrations? I often hear customers ask about, hey, I'm updating my application in this DevOps model, but what about my database? What about my schema? How do I update that in a Kubernetes environment? And so here we're going to go through an example. I have version 1 of my application using version 1 of the database in production, and I want to go to version 2. So I can leverage a tool like Flyway, open source tool to do schema version controlling. And what I do is I define that migration script called version 2. I then pack that version migration script into a container build file. Along with the Flyway application, I build that image, store it in my registry. And so that image will be labeled Flyway, my database version 2. And it'll have the schema change, and it'll have the Flyway executables. And now I want to deploy that and manage my PostgreSQL database that's in my Kubernetes environment. So here I have version 1. Kubernetes can automatically provision a persistent volume backed by NFS or block or some sort of shared storage like Gluster. And so if I want to upgrade that database to version 2, I go ahead and create what's called a deployment of a type job in Kubernetes that basically just runs and executes that instance once. And so the Flyway instance will get instantiated based on that image I just created. I defined the database connection in a secret for this Kubernetes application. And then when it starts, it'll execute the migration script by connecting via JDBC to my Postgres database and applying the version 2 of the schema. So now I have version 2 of my database out there, and I could then upgrade my application from version 1 to version 2. Right? And so as you make this migration, you need some feedback. Here's some monitoring considerations. You're probably used to monitoring at the host level, but you want to get feedback at the container, the Kubernetes, and microservices level as well. Especially as you move to a microservice architecture, you'll want a distributed tracing tool, maybe Uber's Jaeger, or leverage also Istio to manage traffic at a more fine-grained manner, as well as rotating keys for mutual TLS between services. So Istio is based on the Envoy proxy from Lyft. And then Prometheus is a common monitoring solution with Grafana providing a visual dashboard as well in Kubernetes environments. So here are just some tools that you may want to leverage, all open source. And then finally, networking. Here we show you how networking can provide logical environments and multi-tenancy through namespaces. But also as a developer, I may want to define network policy to limit access because by default, within a namespace, pods can all talk to each other. And so a best practice is to disable that communication by default, deny all ingress and egress, and then whitelist the communication that's allowed. And that's at layer 3, layer 4, where Istio is working at layer 7, if you're using that. Okay? So I think we're out of time, but I want to thank you for attending today's session. And here's some other projects that are layer on top of Kubernetes you may want to take a look at as well as you move forward with your journey in adopting containers. So thank you very much. Here's my contact info. Happy to answer questions out in the hallway afterwards, or feel free to reach out to me via email, LinkedIn, or Twitter. Thank you so much.
Thank you so much, Chris, for talking to us.